All right, I'm here with Alpine Combat Systems, and what is your drone?
So we have a quadcopter. It has X11 plus motors from Hobbywing, 43-inch propellers, aluminum frame, and just 3D printed components as far as brackets go.
Yeah, speaking of that, I noticed you have a 3D printer here. That's pretty smart. You brought your own 3D printer?
Yes.
Yeah, so it looks like you can develop and print right here. I should have brought mine.
Yeah.
Can I hop over and take a look?
Yeah, definitely.
Oh, thank you. There it is. Wow. Oh, and I see you got something crazy going on down here with the, I'm assuming it's the weight release mechanism?
Yeah, it's all mechanical. It requires no servos, no electronics, and it's all based on just using.
Oh, wow. Okay. So
using the weight itself. So
it's a quick release kind of thing.
it is. So once you lift up the load, it unlocks, and then center of gravity is calculated already, so it stays center no matter
That's
what.
smart.
We're using 21700 cells.
Oh, you're making your own?
Yes. Okay. So this is the battery that we have.
You're building your own batteries?
Yes, we're building our own batteries. It's a 14S 7P 58 volt 21700 cells, tablets, and we're bypassing the BMS. The BMS is just for charging purposes.
That's fair, yeah. Pushing it to the limit, so yeah.
Exactly.
Yeah.
And then we're just using standard old Anderson connectors that you would find like on a tractor. You just set it on top.
Oh, built-in hard mount. That's clean.
Yeah, bolted on top, bolted down, and it's gonna go.
Nice.
Yeah.
Pretty impressive. So this is Alpine Combat Systems.
Yes, we designed this to be affordable. Altogether, this drone, obviously the most expensive parts are the motors and flight controller, those kind of things, right? But everything probably costs no more than $4,000, $3,500.
Nice.
So it's designed to be repairable with just standard stuff. But 3D printer.
Oh yeah, it's not carbon. You said this was aluminum.
Aluminum.
But the advantage is if this breaks, as we've seen, there's a lot of crashes. So if
Exactly.
it breaks, you can fix it right here.
Yeah, we can go to a local hardware store and find aluminum and fix it.
That's a smart strategy for this competition, for sure. I'm here with Air Defense with their incredible aircraft. So from what I can tell, this looks like a turbine tip jet. Is that right?
Yeah.
That's incredible. So what turbines do you have over here?
What turbines? It's Jet Central Rabbit 100.
Jet Central Rabbit 100s. So you're gonna, these three are all thrust with the custom carbon wings, it looks like?
Yeah, we fabricated this all in our garage very fast, but we made it as light as possible.
I see. And so the controls, you know, a lot of people have different ways of controlling it. So are you adjusting the thrust of the turbines or is it like the angle of the blades?
Well, adjusting thrust of turbines only gives us more or less lift.
Right.
To control pitch and roll, we need to shift weight under. That's our way of controlling.
Should we take a closer look?
So you can imagine here the weights that we lift, the Olympic discs, they would be shifted forwards, backwards, left, right as needed to go in the desired direction.
I see.
But for adjusting the yaw, this control surfaces change angle like ailerons on the wing.
I see too. And it looks like you have two motors on right there. What are those?
Yeah, that's not motors.
Not
that's
motors.
Servo motors.
Servo motors.
Control shifting.
That's the weight shift.
I just talked about.
Oh yeah.
Around this U-joint axis here.
I see. Though that's really cool. It's like those like robot dog servo motor kind of things.
Yeah.
So they're really strong, and so you can
They are.
shift. That's smart. I've never thought of that. That's cool.
We have a battery here. Right now it's missing, we are charging it, but this controls jet engine controllers and receiver transmitters here to communicate with the flight controller on the fuselage.
Oh right, because you can't have a wire, so
you cannot.
You have a short range wireless between
communication.
them. Oh, that's a lot of work too. It's like that's something a lot of people don't think about with these things. It's because that has to spin, that has to stay. So that's pretty impressive. So this is Air Defense Systems turbine tip jet. Pretty cool. Pretty incredible though. I've seen your turbine helicopter. Oh, tip jet,
yeah.
Okay, not just a helicopter, tip jet helicopter.
Yeah, so it's firing the exhaust. We have a junction so we can wastegate and divert.
So you're not even using all your thrust?
Well, this is definitely a bigger size turbine than we need.
I see.
So we're dumping like even at takeoff we're jumping like 50%.
Oh wow.
But it's the wastegate allows us to throttle the
true.
rotor,
That's how you throttle.
and so
That's
it's
true.
much faster
That's true.
response. And then it's just the hot gas goes up, splits, and out to the tips. And the big innovation is in our material design and how we're keeping this 700-degree exhaust from melting our carbon and destroying our epoxy. And that is, we're really happy with that. We've been checking temperatures everywhere. And
Oh, no, you even have a little temperature gauge
Yeah.
on your main rotor. That's.
and so you can see
Wow.
out here,
Oh, you have one right here.
if you look at this one, it's we're not hitting our limit. We're well under spec, so the carbon's all good. I mean, it's held together, and we've had this thing spinning for.
That's a really clever idea. It's like lightweight. You just stick it on. That's so clever. I wouldn't have thought of that.
Yeah, and when it's spinning, it's actually drawing air through, and so the Inconel tube running here that's containing the hot gas is separated by the carbon by essentially an air jacket.
I see. Oh yeah,
And
so
that's-
it's not directly
That's
there.
what's
If you take
keeping
it.
it cool. Yep.
Yeah, it's not a direct connection. I see.
Mm-hmm.
Yeah, because I can imagine you melting your rotor blades would be an issue with
That was
the turbine.
The big question with the concept was, could we make the materials work? And we've proven that. Now we have other issues that are preventing us from flying, but the actual, hot gas system is working as we hoped it would.
That's really great. Yeah, and it looks like it's repairable too. Because unfortunately, I saw your first day tip over.
We had a spill, and I mean, these things are
But you're back
pretty
up in the air.
robust. Yeah, we were able to repair everything and
Nice.
and do. We finished our testing suite this week basically. So we've answered hopefully the questions we need to.
That's good. That's
and
good.
yeah, I think if we get invited back for round 2 next year or whatever, we're confident that we can have
For sure.
this.
That's a
this
solid.
flying. Yeah.
And tip jet turbine is insane to do. It's insane.
We were ambitious. Yes.
Yeah.
And we knew in the timetable that it probably was going to be an impossible challenge. Which
yeah.
we're not the only team here that's experiencing.
Yeah,
it,
4 out of 600. It's kind of like.
so. Yeah, we don't feel too bad.
Yeah, and I gotta say, so I'm new to fuel, and so I'm taking a look at your fuel bags. That looks custom to me.
Yeah,
Custom fuel bags?
These were ordered, commissioned from a professional, but they're designed for RC jet.
Yeah, that's what I
planes,
use
yeah.
too. Yeah, I just bought off the shelf stuff, and you got a guy to do
Yeah,
it?
these we.
I gotta get the name
I
of your
forget
guy.
yeah, you have to ask him.
I'll ask him. I need that guy too.
We actually had a guy come to our booth yesterday holding his vacuum sealer in his bag. Like, can you teach me how to do this?
yeah.
And we're like, we just
Oh,
bought
sorry.
them off the internet.
Oh no. Yeah, a lot of work just goes into fuel things. I've
Yeah,
learned.
yeah.
So it's just like some people might think it's like, oh, it's just a fuel tank, but no, a ton of work.
Yeah, and actually, someone suggested that they might be catching our downforce and giving us part of our resonance issues.
Oh,
which
true.
we
a
hadn't
little,
considered
a little
that
bit.
either.
True.
I
I don't know how much. I mean, I don't. In my opinion, not
Seems
too much, but
unlikely,
we'll see.
yeah.
All right, so that's pretty incredible. This is Team Cactus Labs. You
Cactus
guys got
Labs.
a YouTube?
Yeah, we're Cactus Labs on YouTube, and it's cactus-labs.co.
All right, well, check them out. Pretty cool.
Yeah, I appreciate you stopping by.
Who else would make a tip jet turbine helicopter? This isn't just a helicopter, guys. Like what you're seeing on your little tiny DARPA live feed. This is something else. Here. Just look at this. You're not buying this from Amazon.
Yeah.
You're not.
Yeah, show right down in here. You can see where the turbine is aimed into this
Wow.
pipe. And we actually
So-
entrained some fresh air as well with that.
I see. Is that better for more efficient or?
You decrease your temperature, which can be a benefit.
Yeah,
Increase your density, but it balances out efficiency-wise.
I see. Okay. Very, very cool. All right, I'm here with Advanced Maneuvering, and here's their crazy entry to their DARPA Lift Drone Challenge. So tell me what this is, because it's only 2 blades, right? So
It is,
bicopter?
yeah. It's a bicopter officially,
Oh.
but it's actually not where we started.
Oh, interesting. Okay.
Yeah, do you see that right there?
Whoa,
Yep.
that's a jetpack.
Yes.
A literal
yeah.
jetpack.
Yeah, I flew that, and that's where we started.
Wow. Okay, so like that was going to be the base for your drone. That makes sense.
No, not at
Oh,
all,
oh.
actually. We started 2019 approximately and started
Oh.
iterating ideas for how to do the actual jetpack, and We
I see,
developed
I
it
see.
from there and came up with a couple of things that we really needed to do to make jetpacks ubiquitous and functional. And that's how we built this.
You've been at it for a while, yeah.
Yeah, we've been at it for a little while, but we ended up getting it to where it's controlled and stable, and it has a flight controller built into it, and it takes input from the arm orientation for all the user controls.
That's really smart, yeah.
And around that time, we realized, holy crap, we don't need a pilot.
Yeah, there you go. So you have a drone, yeah.
And so we could hook up controls to it, or an RC controller, and actually have it fly itself.
That's insane, yeah. So, but then now you're,
Yeah,
I mean,
and then we went
efficiency,
to
right?
this.
Efficiency, is it?
Yeah, huge efficiency.
Because Blade's
shift.
better than Jet.
Yeah, so those jet engines there are brute forcing their way into there.
Yeah.
They take their fuel and they just throw it out the back at over 1,000 miles an hour to try to throw themselves into the air.
Yeah, I looked at it. It was like some of these are like 1 gallon a minute or something. It's crazy like that.
That pack drinks a gallon a minute.
Right? Yeah, a gallon a minute. That's
For
crazy.
all 4 engines, it drinks
yeah.
it up fast.
Yeah.
So the fuel efficiency just wasn't there. The
So that's
thrust
why
efficiency
Blades,
was awful.
turbo shaft.
Yep, so that's why we went to turbo shaft here. And these engines, with our props that we got on it, will actually do 140 pounds of thrust.
Each. So yeah, that's a lot of, yeah, wow.
So total 280. Huge gain. And yet they sip an eighth of the fuel.
Wow.
So it changed that from having a 5-minute flight
Yeah.
time, fully loaded, to having 20 minutes of flight on this.
That's pretty incredible.
And doing about the same payload capacity.
Yeah. And I will say, I've built my own bicopter before. It, of course, a little electric one, and that was so tough. Like, how did you? Because
the math is hard.
You have a servo here, right?
Yeah, we've
Servos
got
on
double
each side.
servos. So we got one right here for pitch and one
Yeah.
right here for roll.
Yeah. Oh, roll. You have roll too. I did. Oh wow, I didn't know that.
It's a bit of a unique setup.
Because
Most of them don't do it.
I only did the pitch. Yeah. What does the roll do in this case?
Roll is actually maybe a vestigial system. And it was all coming from that. Because with a jet engine, you take 10 seconds to spool up.
Oh wait, I forgot about
We
that.
needed some way to react faster.
Oh yeah, because jet engines they have a lag because it's like it's not an electric. You know,
Yep.
it's not instant, so you need a
Yeah,
faster
so
control.
instead what we do is we flare out to the side with our thrust and we burn hotter. And then when we need it, we can just flick it down and use it right when we need it.
That's really smart. Okay, I was just like, wait, why do you need roll in a bicopter? Of
Yeah, I
course,
know, it's weird.
You have a turbine, so it's like you get, advantages, trade-offs. There you go.
Yep.
But you figured it out.
Yep.
And what is going on in here? Because that's not a Pixhawk. That's not a Cube Pilot.
Far from it.
What is?
Far from it. This is a custom homespun board, specifically for this. If we look at the other one over there, you can see our AMP ECV 0.9.
Oh, you've
This
made
is
that
our
board.
company. We custom spun this board for the advanced maneuvering pack
Wow.
right here. And like everything on it, we did custom. The
All
controls are
custom.
custom, the software is custom, the hardware is custom, the
Yeah.
airframe's custom.
Yeah, like most of us out here, we're using like COTS stuff. Pixhawk,
Yeah.
Cube Pilot. You buy it for $200. You guys made it, so that's
Yeah, we made
that's
it
the
from
next
scratch.
level.
And that's because bicopters are so much harder. The math isn't really out there. It's not super well understood, and it's all cross-coupled. When you go for forward translation, you're going to generate a healthy pitch. And most systems don't operate like that. very well.
Yeah, it's not many people building bicopters, let alone you probably have the only turbine bicopter, I think. So
Yeah,
that's
there's a
pretty
couple
crazy.
over there that are trying to do it too, but they didn't get quite as far yet.
So yeah, this is insane. So this is
Yes.
advanced maneuvering, just crazy.
Yeah.
Turbine bicopter, amazing work. And of course, it's just like, it's just carbon fiber and
Yeah,
custom carbon fiber, of course,
But
at
it'll look
this-
sexy.
Yeah.
right?
I can't believe, just like everyone's doing custom carbon fiber, and that's just like the tip of the iceberg right there.
Yes.
Yeah, so there you go, advanced maneuvering.
Do you want to try on the jetpack?
Oh, okay. Oh, I guess it's gonna be
Hop
like
over.
good. Okay.
You want to get a picture?
We'll just do the video. It's fine.
Let me give you your mic back here.
It's okay. Keep it. I got one. Okay, this is cool.
Yeah, just throw it on your shoulders
Just throw
right
on
there.
your shoulders right here.
Yep. And like we were talking earlier, the controls are actually mounted on your arm. So this is actually one of the controllers. You'd have one on both sides.
Oh, it's a
And it'd
little
mount right there.
little accelerometer gyro thing here.
Exactly, yeah. We've got some IMUs on there.
That's cool. So I can do like okay.
Yep. So you fly like Iron Man. The way you fly is just where your arms are oriented.
That's cool, and I think it's a bit. I've seen some other jetpacks that I think are a little bit lamer because they have turbines on your arms.
It's harder.
It's like that doesn't
and
look.
it takes a lot of training.
That I don't think that's the way to do it.
That's
So
one of the concerns we had.
This is the way to do it, I think. So that's the way.
I'd like to think so, yes.
How much does this weigh?
110, fully fueled.
Can I try?
Yeah. Right now it's empty, so it's going to be more like 70.
I'm gonna embarrass myself.
Yeah, just lean forward a little bit.
Okay, nope. I'm gonna. Okay, I gotta hit the gym.
But that's why it's like this was our first gen. We had to learn somehow. We had to build up our understanding and experiment and just try it, and maybe crash a few times. And crash we have. We actually blew up 3 of our engines in one instance.
Wow.
It was the most devastating moment of my life. We went to do a test rig and we had them all bolted down, vectored up like this so that we could test total thrust capacity, engine runtime on set amount of fuel. And we start the engines. And if you've heard these, they roar.
Oh,
and it's this visceral thing just and you feel it in your chest as the air thrumps. And we're spooling up, and I see some sparks fly out the tail end of the exhaust.
Oh no.
And I say, well, that's a little bit weird. And then, boom! And engine blows its faceplate off.
Oh no.
3 of the engines rip themselves from the mooring. There's fuel spitting out. Everything's on fire.
Yeah.
There's diesel on fire. The board's on fire. The mount's on fire. The grass is almost on fire, and so I start pulling stuff out from the fire and stomping on it and blowing on it, pull out the LiPo and toss it so it doesn't explode. And it was just nuts, but it's like we took a huge loan to do all of this, and that was everything just gone.
But like it's the process. What a lot of people don't know is like crashing is part of the process. It's not a failure.
Yeah.
Because it's like if you see people out there crashing, it's not a fail. It's like we're learning every time.
Every single time, it's what do you take from? What
You
did
have to
learn?
crash. What happened?
Yeah.
How do we fix it? It's part of the process.
Exactly. And you just learn so much from all of that. That's half the point of being here, is just to push the boundary.
Yeah. All right. I'm here with Somewhat Engineering over here, and look at their drone. So it's a tricopter with more motors. So 5 motors, but mainly it's a tricopter, I think. So, like, what is this? Like, tricopter, I think it's the one only true tricopter here, I think.
Yeah.
What's the reasoning?
So really we ended up with this design kind of on like happenstance. We were initially going for a quadcopter, and we ended up losing one to ESC. And
Oh
so
no.
The next configuration is obviously a tricopter, so we didn't have a servo in hand to do the tilt.
Oh yeah, because tris need the servo, so you put a motor. That's smart.
So we put a motor over here to kind of counter the.
Yeah, that's how
yaw.
you do the yaw. So really
and then
really smart. Yeah.
Our idea was we want to keep the craft pretty level to the ground, so it does most of the lifting. Because once you start tilting forward,
Oh yeah, that's
you lose.
a problem. A lot of people have the dynamics of you tilt it and then they lose their tune, basically.
Right.
So it looks like yours looks like a spaceship, but yeah, you have thrusters,
so we have
basically.
thrusters,
That's
They'll
cool.
be pulling the craft forward.
See, that's a smart way to do it because a lot of people out here, they're not tuned to their drones aren't tuned to carry the weight. So once they tilt, they lose that tune. And so your plan is to never tilt, which is smart. You don't tilt, so you don't have to worry about that kind of tuning.
Yeah. And then in the programming side, I configured some parameters to where it only lets it tilt like about max 10 degrees.
Yeah.
Same with the lift.
Good luck. And you're about to go on the flight line like right now in
Yeah.
like 1 minute. So best
Yeah,
of
we're
luck.
just
I don't want
waiting.
to take up your time.
It's okay.
So congrats on making it this far.
Yeah, thank you.
Good job.
Impressed with some of the micros that are out right now. There's no one way or anything like that, but motor tail.
All right, I'm here with Team Energetic Flying Nuisance, and this looks like my workbench at home, so I feel very much at home right here. This is your drone, and I can see you have 4 nitro engines.
Yes.
What is
we're
that?
One of the few teams that are running nitro engines. Those are generators.
That's hybrid.
Yeah, it's a
I want to
hybrid.
build a hybrid so bad. It's in the works, and you guys did it. It's 4
We
nitros.
did it. It kind of works.
To do it is pretty impressive.
Yeah, we're getting a lot of issues, but they do run, and they do generate power.
That's pretty amazing. What generators do you have? The motors, brushed?
They're just they're EDF motors.
EDF motors. Okay,
Brushed.
brushed.
They're brushless 3-phase.
And then, are you running it through like a VESC or like the diodes or
It's rectifier.
rectifier? I see. Okay.
Yep.
Very cool. Very cool.
putting out, I think it's
so one of
phase DC?
2 hybrid drones here, and the other one is just your neighbors right there, which is crazy.
Yep, but I think they were having issues with their hybrid system too, and they were talking about running strictly batteries.
Yeah, I think they switched over.
I'm not entirely
yeah, they,
sure. He
they
told
did,
me that earlier.
Yeah, they switched over to just batteries, so it's a lot of work to get hybrids to work.
Yeah, it's been very particular.
Yeah, it's so.
Because it flies, same as them.
Yeah,
It flies on
just-
just batteries.
It's a lot of work to
And now
go
we just
into the
need the
hybrid
juice.
system.
Energetic flying nuisance. And
So-
yeah, I know, it's a mess. We basically brought half the garage.
Yeah, this is not a mess. Trust me, you should see my workshop.
Well, this is a lot better than it was because we kind of constructed this thing last week. Like we were build prototypes, we were doing testing up until this point, and then last week it was just hammer, like
Nice.
up till 3 a.m.
And you guys made it.
finish We're here. We attempted a flight on Wednesday. It didn't work. We had a flight window today, and we found some fueling issues with our nitros. It was an oil mixture problem. We have the wrong oil mixture, not enough.
Wow. So yeah, good luck. You're still in the running. I wish you the best. I hope a hybrid drone can make it.
Yeah,
I love
I
hybrid
want to
drones.
see. I just want to see a flight.
Yeah.
I just want to see a flight. We've had so many issues up to this point. We're hoping to get it up this weekend.
All right, I'm back here at Snyder LaPenna Composites. This was my favorite drone, and there's unfortunately been some updates to the drone. Can I come around and take a look at it?
Absolutely.
So you guys are going to get the full scoop later, because I've talked to them when their drone was in one piece, and this was my favorite drone because you guys have put this isn't one idea for a drone. This is like 10 good ideas into a single drone. Tip jet, turbine tip jet,
Yes,
but your turbine is in the middle.
Yes.
And so you got pipes going through, like, I guess we can see them now. It's those ducted.
Yeah, I'll grab the models for it.
Look at that. And so yeah, he's been explaining to me this is 3D printed metal that they're using over here. Pretty incredible technology. And so they're ducting that exhaust from the turbine through their rotor blades to the tips like that. So first of all, it's crazy engineering to go through there, and you got to tell me again about the heat. So how do you guys manage the heat?
Well, you see here in the exploded view, we have the assembled view and the exploded view.
Yeah.
So we have a jacket here with ceramic insulation that's wrapped in foil tape. And that's actually done a really good job keeping the heat inside of the pipe. And that's one of our goals, is to actually keep that heat inside the pipe up until the instant it leaves the nozzle. And then at the same time, we're trying to keep the skins of the aircraft cool. So we're relying on the rotation of the wing
to cool
in order
it.
to have some sort of air blowing over it.
see.
And then as soon as we shut this motor down, we're immediately putting a leaf blower right on the top here to blow cold air back through the system. That's been our biggest challenge, is dealing with the heat in this.
And you have to tell me about your payload release mechanism, because I'm so excited about that. It's so clever
it's
and simple.
well, it's not installed on here right now because of the crash.
But you have it's just this slot.
Yes.
It's just a slot.
Yeah, so what we have is we have a 3D printed piece that slides into this slot, and it's wrapped with it's almost like a nichrome wire, something you would use for
Like hot wire.
Yeah, kind of like a hot wire.
It
for,
heats up when you put
right,
current through.
Right. So in our flight controller, we added an extra module in our flight controller that switches a relay on and runs current through that wire around our 3D printed part, and then we melt that 3D printed part, and it basically breaks and drops the weights.
That's so smart. It's crazy. So it's like they don't need to go out to the drone to release the weights, and like they just do it automatically from the flight controller. That's really clever. That's why I'm like, this drone has like 10 like really good ideas. It's just all this, like, look at those encoders you got there. Let's just like so much.
Right. And here's another this tiny little cooling fan actually. This cools our electronics that are directly mounted below our exhaust system.
Oh wow.
Okay,
So
because we have what is it called? It's basically the rotating shaft where we send the electronics through.
yeah, I forgot what slip ring.
Slip ring,
There
yeah.
you
So
go.
our slip ring is actually located right here.
And it would overheat, right?
Right. So we actually have a cooling channel here where all our wires are located. So we have a heat shield above that, and then we run atmospheric temperature air through that in order to keep those wires and the slip ring cool without being insulated inside the rest of our exhaust system. So that was a
Wow.
really important thing we realized that we needed.
Yeah, it's
this is a
like-
bit of an afterthought. You can see we had to cut that out.
But still, it's just the amount of engineering that goes into all of these devices is insane. Like when you're watching this on the TV, like you just see like a drone, and it's like, oh, okay. But once you're up and close and personal with it, there is just so much going on in here, so much engineering. There's 100 different little features in it. It's amazing. So amazing engineering work.
Thank you. And one thing I'd like to add is because of the cooling of our engine, that actually necessitated the release mechanism because we did not want to slow the wings down and shut the engine off
because then you
to release the weights because we
might overheat.
Right, so we needed to keep the active cooling of the wings moving through the air to keep the wing skins cool enough while the engine was running. So that's actually how we came up with the design.
It's
for
like the movie
release.
Speed. You can't stop. If you stop, you're gone. So it's like
stop.
you literally
Once it
cannot
goes,
stop.
You cannot stop this.
That's why I love this drone so much.
So we take it once we do stop. We have to take a leaf blower up to the top and actually force cold air through the system, cool it down quickly.
What an incredible piece of engineering. This is Snyder LaPenna composites.
Wait, so if it rains out at 4, we get rain.
Are you busy right now, or?
Well, we're pushed back and forth, so
That's good. Okay, you want to mic up?
what are you guys?
I'm Hoarder Sam, YouTube.
Hoarders. Hi. How you doing? Oh, no, sorry, these are DARPA.
Oh, sorry.
Hey, we're with the broadcast.